Imagine a world where AI felt like, well, pure science fiction. Computers couldn't reliably tell a cat from a car. Forget about understanding a whole scene.
Right, it seems almost quaint now.
Exactly. And then it felt like almost overnight, everything changed. At the heart of that massive shift, one individual, Dr. Fei-Fei Li.
Often called the godmother of AI. It's quite a title.
It really is. Her career is practically a roadmap for modern AI, starting way back when the AI winter was just thawing. And now, she's pioneering the next big thing, spatial intelligence.
Hmm.
So our mission today is to really dig into her journey, pull out the key insights, understand how these foundational breakthroughs happen and get a sense of what's next, all through her lens.
And what's so fascinating, I think, is how her vision consistently seems to predate these huge shifts.
Yeah.
Yeah, and then drive them. Things that sounded, frankly, delusional back then are now just standard AI practice. It really speaks to having these audacious bets and just sticking with them.
Okay, let's unpack this. Let's go back. Picture the scene, say, 2007 to 2009. AI and machine learning.
Totally different world.
Right. Very little data. Algorithms just weren't cutting it, especially for computer vision.
Nope. Spinning wheels, mostly.
Real industry around it. The public barely knew the term AI. And right in the middle of that, you have Dr. Li, a first-year assistant professor at Princeton.
Just starting out.
And she has this really personal dream to make machines see. But why seeing? What was the specific problem she was zeroed in on?
That's a great point because her dream wasn't just about sight. It was tied to this really core problem that she said haunted her.
Generalization.
Generalization. Okay. Yeah, the ability for an algorithm to learn from some examples and then actually work on new stuff it's never encountered before. To be truly adaptable, intelligent.
And that needs data.
Desperately needs data. But nobody in computer vision really had it then. She was like part of the first wave of grad students who even thought about using the internet to get data. She saw its potential early on.
So, okay, limited resources, lots of skepticism. What was the move? What did she and her student decide around 2007, that bold bet?
It was incredibly audacious. They decided to just bet everything on data, a data-driven paradigm shift.
Wow.
The plan: download 1 billion images from the internet. That was like the biggest number they could even imagine then.
1 billion, okay.
And use them to create the world's first big visual taxonomy, a massive data set to train it and, crucially, benchmark machine learning algorithms.
And it wasn't just collecting it, was it? They knew this had to be bigger than just them.
Precisely. Yeah, they couldn't do it alone. So right from the start, they open-sourced ImageNet.
Yeah.
Made it available to everyone.
Smart.
And they treated the ImageNet Challenge, a yearly competition, basically inviting the whole world to come play, innovate, and push the boundaries. It built this whole ecosystem.
Okay, so they launched this, open sourced it. For 3 years, 2009 to 2012, not much happened. Crickets.
Pretty much. I mean, incremental progress, but no big breakthrough. Imagine waiting that long, holding on to that bet.
Yeah, tough.
Then, summer 2012. Late one night, Dr. Li gets a ping from her grad student. Standout result. From Jeff Hinton's team, supervision. And the surprising part, they were using an old algorithm, convolutional neural networks, CNNs.
CNNs from the 80s.
Yeah, exactly. They were good for image patterns but hadn't scaled. The real innovation, the key thing, was using 2 GPUs together for the deep learning computation. First time that had really been done effectively.
Okay, so that was the moment. It wasn't just one thing, was it? It was everything coming together.
Exactly. It's that convergence. You had the data, ImageNet. You had the algorithm, the CNNs, revitalized. And you finally had the compute power with the GPUs.
Right.
ImageNet didn't just give people data. It created the whole stage, the challenge, that allowed these algorithmic and computational breakthroughs to actually happen and be recognized.
It kicked off one of the main legs of the modern AI stool, as she put it.
Absolutely. Huge turning point.
So building on that, ImageNet basically cracked object recognition, identifying a cat, a chair, labels for things.
Yep. Solved that problem, fundamentally.
But Dr. Lai had this deeper ambition, right? Since grad school, not just naming objects, but
telling the story of the scene, understanding the context, the relationships, what's happening. Not just cat, but cat sitting on a mat in the sun.
And she thought this was, what, a 100-year dream? Something she'd be working on forever?
Literally. She said she thought she'd be working on it until her deathbed. That's how hard she thought it was.
Wow. But
then, deep learning happened. Post-AlexNet, things just exploded. And suddenly, natural language processing and computer vision started.
Well, colliding.
Colliding, how so?
People started figuring out how to connect models that understood images with models that understood language. And around 2015, she and her student, Andrej Karpathy.
Ah, Andrej Karpathy, another big name now.
Right. And they published these papers that were among the very first to let computers actually write captions for images.
So the 100-year dream.
Achieved shockingly fast. Her lifelong goal basically realized almost overnight, relatively speaking. That's incredible. And there's that anecdote you mentioned about her joking with Karpathy.
Oh, yeah, it's great. So after they got image captioning working, she jokes with him, okay, now let's do the reverse. Take a sentence and make an image.
And his reaction?
Right, like, yeah, right, I'm out of here. Like total dismissal. The tech just wasn't there, seemed impossible.
But now,
look at generative AI. Diffusion models, stable diffusion, mid-journey. That's exactly what they do. It just shows how insanely fast the field moved, faster than even the visionaries predicted sometimes.
it really is humbling. Even the wildest ideas can become real faster than we think. Which actually brings us perfectly to her current goal.
The next audacious bet.
Exactly. The arc went from objects to scenes, and now she's aiming for understanding and generating entire worlds.
Right, as CEO and founder of World Labs. And she explicitly says this problem is even harder than objects or scenes.
So what's guiding this new North Star? Where does the inspiration come from?
It's really interesting. She draws heavily from biology and evolution. She makes this comparison. Human language, evolutionarily speaking, maybe took a few 100,000 years to develop.
Right.
But vision, understanding and navigating the 3D world, evolution spent 540 million years on that, starting way back with the trilobite.
540 million years. Wow.
Yeah.
Why is vision so fundamental evolutionarily?
Because it seems to be the thing that kicked off the whole evolutionary arms race. Before complex vision, life was simpler. That ability to see and comprehend the 3D world drove the development of more complex brains and behaviors.
So her argument is?
Her argument is that AGI, true artificial general intelligence, won't be complete without spatial intelligence. World models aren't just about flat pixels or text. They need to capture the real 3D structure, the physics, the spatial nature of reality.
Okay, so why is that so much harder? What makes spatial intelligence this Mount Everest of AI problems?
Well, several things. First, dimensionality. Language is like 1D sequential data. The real world.
Right.
It's 3D. Add time, it's 4D.
Right, way more complex.
Combinatorially much harder. Then there's sensing. Our eyes, cameras, they project 3D down to 2D. That's inherently lossy, mathematically ill-posed, meaning you can't perfectly reconstruct 3D from a single 2D image.
Which is why we have two eyes and other senses.
Exactly. We need multiple sensors, multiple viewpoints, context. And the world isn't just generative like language models can be. You can generate plausible text, but the real world has physics. It has structure.
So you need both generation and reconstruction.
A fluid interplay between them, generating possible worlds, but also reconstructing the actual world based on sensory input and making sure it all obeys the laws of physics.
Then the data problem again.
Huge problem. Where's the data for 3D spatial understanding? It's not just sitting neatly on the internet like text and images were. It's, as she says, all in our head, our internal models of the world.
How do you capture that?
Very difficult. Plus, even our own brains dedicate vastly more resources to vision and spatial processing than language. We don't even fully understand how we do 3D perception perfectly.
Okay, this sounds incredibly challenging. It must require a seriously specialized team. Who did she bring together for World Labs?
Yeah, she calls it a crack team. 3 co-founders, all world-class technologists. Justin Johnson, known for systems engineering, neural style transfer.
Right, I know that work.
Ben Mildenhall, the guy behind the NERF paper, foundational for neural rendering.
Got NERF, yeah, huge.
And Christoph Lassner, creator of Pulsar, which is key for differentiable rendering, making these 3D scenes learnable.
That's quite the lineup. And how are they tackling that data scarcity issue you mentioned?
They're using what she calls a hybrid approach. Learning from ImageNet, it's not just about quantity, but quality too. You need both. Avoid garbage in, garbage out. So likely a mix of real-world data, synthetic data, and clever learning techniques.
So tackling these incredibly hard problems, it's not just academic, right? This could fundamentally change how we interact with digital worlds.
Oh, absolutely. Think about it. If spatial intelligence is as foundational as evolution suggests,
then mastering it in AI could reshape everything. Exactly. Our daily lives, entire industries. The applications she sees for these world models are vast. Creation tools for designers, architects, artists, game developers.
makes sense.
robotics, obviously, giving robots real spatial understanding, marketing, entertainment. And she's particularly excited about the metaverse.
Ah, the metaverse.
Yeah, she sees a big need coming for both the hardware and, crucially, the content creation tools to build rich, interactive 3D worlds. Spatial intelligence is key to that.
It's fascinating how her technical work is so forward-looking, but her personal journey is just as remarkable. It's a real 0 to 1 story.
Absolutely. Immigrating to the U.S. as a teen, not speaking English.
Yeah.
And that story about the dry cleaning shop.
Right. Tell us about that.
At 19, just 19, needing to support her family while studying physics at Princeton, she starts a dry cleaning business. In Silicon Valley, no less.
Wow.
She was the founder, CEO, cashier, everything. Ran it for 7 years and then successfully exited. It's just this perfect early example of her core philosophy, hunker down and build. That's incredible. It wasn't a one-off, right? This pattern of taking the unconventional path, building things from the ground up, seems core to her career.
Totally. She consistently chose paths others advised against, being the first computer vision professor in departments that didn't have one, then going to Google not just for research, but specifically to learn business, cloud, B2B.
Interesting move.
And then returning to Stanford to run the Human-Centered AI Institute, HAI, basically like a startup for 5 years, with this mission to ensure AI benefits humanity.
So it's this love for starting at ground zero.
Exactly. She said she loves that feeling. Forgetting the past, ignoring what others think, just focusing, hunkering down, and building. That's her comfort zone, she says, which is pretty amazing.
And this seems tied to what she looks for in others, too, her students.
Yeah, she mentioned her core hiring criterion, something she saw in all her really successful, legendary students. Intellectual fearlessness.
Intellectual fearlessness.
The courage to just dive into hard problems, be all in, not worried about failing or looking silly, just pure commitment to tackling the challenge.
And for listeners who might be thinking about research, maybe grad school, any advice from her?
Yeah, she had some specific thoughts. Graduate school, she says, is really for that burning curiosity. If you have questions so consuming that grad school is the only place to pursue them.
Differentiating it from, say, a startup?
Right. Startups have commercial goals.
Yeah.
Academia is often about that foundational, curiosity-driven discovery.
In specific areas she thinks are ripe for academic focus now.
She mentioned a few things. Interdisciplinary AI, using AI for scientific discovery in other fields. Theoretical problems like explainability, causality, where our AI capabilities are kind of ahead of our understanding. Representational problems in computer vision, still lots to figure out there. And challenges around small data, how to learn effectively without massive data sets like ImageNet.
What about AGI? That term gets thrown around a lot. Her take?
It's nuanced. She sort of struggles to see how AGI is fundamentally different from the original goal of AI back in the 50s, and, machines that can think. She sees it more as just the progression of the field rather than some distinct new destination.
Interesting perspective. And on open source versus closed source AI?
She seems pretty balanced, believes the ecosystem needs both. Different business models call for different strategies, open or closed, but she strongly, strongly advocates for protecting open source efforts.
Why protect them specifically?
Sees them as vital. Vital for entrepreneurs, for the public sector, for keeping innovation flowing freely.
Finally, thinking about her own journey, facing challenges, being an immigrant, a woman in STEM, maybe feeling like the only person in the room sometimes. Her approach.
Her personal take is try not to over-index on it. Don't let it consume your focus. Instead, focus on the learning, the creating, the work itself. Her phrase was basically gradient descenting yourself to the optimized solution.
Using an AI term for life advice.
Pretty much. It's about focusing on the process, the path forward, iterating towards your goal. A powerful message of resilience, really.
Absolutely. So, Dr. Fei-Fei Li's impact. It's hard to overstate. Seeding the data revolution with ImageNet, which really unlocked modern deep learning.
Foundational.
And now pushing AI into this incredibly complex realm of spatial intelligence, of world models, always tackling problems others might call delusional.
And that entrepreneurial spirit runs through it all. From the laundromat to world labs, coupled with that intellectual fearlessness. It hasn't just shaped her career, it's shaped the whole field.
It really has. Which leaves us with a final thought for you, the listener, to chew on.
Okay.
If evolution took 540 million years to build our human understanding of the 3D world through vision, And AI is now trying to replicate and maybe even expand on that, but at this exponential pace.
Yeah, what does that mean for us?
Exactly. What fundamental shifts in how we live, how we create, how we interact with reality itself?
Yeah.
What might we see in just the next few decades, all driven by this quest for spatial intelligence?